Hello, my friends. Now let's look at our NJSLA practice question number 25. Number 25, consider the following claim. If the point 2 plus d comma y is on the graph of a function f of x equal x times parentheses x minus 4, then the point 2 minus d comma y is also on the graph. Now we need to use algebra to show the claim is true. Let's look at this part. For first, given function f of x equal x times x minus 4. And the question said if the point 2 plus d comma y is on the graphing. Okay, remember the order pair is always x comma y, which means x is 2 plus d here. Now let's substitute the first given condition back to our function to see what's going on. F of x is your y. Therefore, I'm going to write as y equal 2 plus d, which is x, I substitute here, times another x is 2 plus d, and then minus 4. Then simplify 2 plus d times d minus 2. So addition is commutative, which is d plus 2 times d minus 2. Using the difference of product, you'll have d squared minus 4. Someone said, well, if you forgot the formula for the difference of square, you can use a 2 by 2 table multiplied out with d positive 2, d negative 2, first parentheses, multiply second parentheses. D times d is d squared, positive 2d, and negative 2d, and negative 4. Diagonal is your like term, however, positive and negative, they canceled each other. Therefore, your product, which is d squared minus 4, equal your y. This is what we have for the given point. Now, the question asks you to prove this 2 minus d as your x is also on the graph. Now, let's see how can we apply for it. 2 minus d comma y. And remember, this is your x, this is your y. And that's the given function. So substitute x and the y. You have y equals 2 minus d times 2 minus d minus 4. Okay, now let's see what's going on for here. We have 2 minus d and negative d minus 2. Okay, so in that case, if you want, you still can flip it over. Then you have a negative d plus 2, because your 2 is positive here. Then negative d plus 2 and minus 2 is still the difference of perfect square, a plus b times a minus b equals a squared minus b squared. If you want, you can apply it. If you do not like it, you still can use the 2 by 2 table. 2, negative d, and negative 2. This is the first parenthesis multiplied by your second parenthesis, which you have negative 2d. And negative times negative is positive d squared, negative 4, and positive 2d. Okay, as you can see, since I did not put them in order, because 1d is behind, 1d is in the front, therefore, it's not this diagonal is like term, it's that one. You have positive 2d, negative 2d, they're going to cancel each other. You have d squared minus 4 for your y. And when we compare those two parts, we have y equals y. Therefore, we proved that if 2 plus d comma y is on the graphing, 2 minus d comma y is also on the graphing because they are going to equal to each other. Okay, so there is nothing like really difficult here for the first part. You just need to substitute your x comma y and x comma y separately back to the function, and then you're going to get the same solutions. Therefore, you proved 2 plus d comma y and 2 minus d comma y, they both on the graphing. This is the first part. The second part of question 25. What is the relationship between the line x equal to and the graphing? As you can see, x equal to is your axis of symmetry here. How to find it? You can use the given function, distributive law, where we have x squared minus 4x. Now, what is our c here? C is 0 because there is no c. Standard form ax plus by plus c. And the line axis of symmetry or line of symmetry formula, which is x equal negative b over 2a. So in that case, we have a is positive 1, b is negative 4. So substitute everything. Negative 4, b is negative 4, negative signs here. 2 times 1, which is positive 4 over 2, which is 2. Okay, you can explain as x equal to is the line of symmetry of the graphing. Also, if you want, you can explain because d and d are the same distance. If you plus distance is on the graphing, you minus the same distance is also on the graphing, which means this is a d, and if you minus d, it's also on the graphing, which means x equal to is your line of symmetry. You add a d, point right here on the graphing, you minus d, same distance, the point is also on the graphing, which just tells you your x equal to is your axis of symmetry or is a line of symmetry. Okay, quickly recall for question number 25. In order to show the claim is true, you substitute your x comma y back to the function and x comma y back to the function and prove that they are equal. Then you showed all your work to show that if this point is on the graphing, the minus b part is also on the graphing. In order to show x equal to the relationship with your function graphing, you can use the formula to find out the line of symmetry to prove that x equal to is your line of symmetry. Or you can explain by word. If you add the distance, the point is on the graphing, and then when you minus the same distance, the point is also on the graphing, then the x equal to, which is your line of symmetry. For me, I prefer you go the top part because that will prove it. And for the explanation part, if you made like some mistake, you might get points off. Okay, so this is all for question number 25.